Hi guys, today we're going to see the lowest common ancestor of a binary tree problem. So it's a medium problem as you can see. So given a binary tree, we have to find the lowest common ancestor of two given nodes in the tree. So according to the definition of LCA, the lowest common ancestor is defined between two nodes P and Q as the lowest node in T that has both P and Q as descendants, where we allow a node to be descendant of itself. So given the following binary tree 3, 5, so you are seeing this tree. So if you want to find either the lowest common ancestors, or P is equal to 5 and Q is equal to 1, okay, 5 is here and 1 is here, right? So if you see, the common parent of these two is 3, so the lowest common ancestor of nodes 5 and 1 is 3. Okay, let's see the example 2. So if you see, the same tree is given and they are saying 5 comma 4. 5 is here and 4 is here, and 5 is the parent of 4. So the lowest common ancestor of 5 and 4 is actually 5. So nodes section says that all of the nodes values will be unique, P and Q are different, and both values will exist in the binary tree. Okay, so if it is a binary search tree, we can use the order characteristics, like given two numbers, if those two are actually greater than the root, then we can search in the right subtree, and if both the values are within if they are lesser than the root's value, then we can search it in the left subtree, and if it is not the case, the one value lies left and the other value lies in the right subtree, then it means, like, root is the lowest common ancestor. But this is a binary tree, this is not a binary search tree. Okay, so how do we do that? We can do it through recursion. So to make sure that the nodes are existing, although they're saying P and Q are different and both values will exist in the binary tree, we should ensure that P and Q are existing in the binary tree. So we are going to have a recursive function which will take in the root value and P and Q. So we will go towards the left subtree and checking whether we are encountering that particular value, and then we'll go on the right subtree and then we'll check whether we're encountering any of the values. And if at all we are encountering values, we accordingly set that we have found the value in the left subtree, and then we have found the value in the right subtree. And sometimes it may be the case that, in the case of 5 and 4, here you see that 5 and 4 is given, and 4 is actually rooted behind 5. That is, 4 is a descendant of 5, right, basically. So in this case, the mid element, right, the rooted element itself is being given as one of the node values whose ancestor has to be found. So in that case, we'll set that the root itself is an ancestor, and so accordingly we set the LCA and return. So what I'm going to do is I'm just going to have a variable. This will be your, as you can see, this returns a tree node, which means they're expecting LCA as a tree node to be returned. Okay, so I'm just going to name it as LCA. Okay, and since we are calling a recursive function, let this be a private function. Okay, I'm just going to say root, and I'm basically passing the same thing, and within this we'll try to find the LCA. Okay, and so this is a private method, as I said. So find LCA. Here it is tree node root, and then basically I can copy the same thing, okay, for this function. Okay, so this is going to be a boolean function. Okay, this is going to return a boolean value. So initially we'll do the sanity check. If at all, if root is equal to null, then we cannot find the LCA, so which means we return false. Otherwise, let's have a variable called left, which will tell us whether we were able to find one of the values in the left subtree. Okay, and if at all, if you have found it, we'll set this value as 1. Okay, because if you see, left is actually of type int. Okay, and we'll also have a right variable which indicates whether we are able to find the other value in the right subtree p comma q, and if we have found it, right, then we're going to set the value as true, and not, we are going to make it as false. Then we'll also have another variable called med, or medal we can say, and where we are just comparing root is equal to p, or root equal to q. As you can see the second example, right, where p is equal to 5 and q is equal to 5. In this case, at root, if at all if we are at root 5, then we'll see whether root is equal to the p value or root equal to. If this is the case, then we'll also return 1 with 0. Okay, and if left plus right plus mid, this is greater than or equal to 2, which means that we have found it in the left, we have found it in the right, and one of the values is mid as well. So in this case, we can safely set LCA as the root. Otherwise, if at all when we are recursing, and just say if at all we have found one particular value, then we have to make sure like left plus right plus mid should be at least greater than 0, because at least we should find one. Okay, so by the time we come out of this function after the recursion, we would be having our LCA, and that LCA can be returned. Okay, let's quickly run this program. So it's accepted. Let's submit this, and you see it is a successful submission. Okay, so this is basically a simple recursion, and we basically recurse to the left and right, checking whether we are able to find the presence of the nodes in the left and right subtrees, and if it is, if you're able to find it at the root, then also we are able to set a particular kind of flag. And then if it is found in the left or right, or it's part of the mid, and if it is greater than or equal to 2, then we set LCA as root. So basically LCA all will be having the value, and we're returning the LCA, which is actually required by this function. Okay, I hope it was clear. So thank you guys, please like my video. Bye.